In the world around us, we often interact with water in its solid, liquid, as well as gaseous form. Do you know that these are interconvertible? In this video, with the help of thermal energy, we will see the interconversion of water. To understand the interconversion of water, let us take ice cubes and observe the changes that are happening in them with the addition of thermal energy. So, can you answer me, what happens when thermal energy flows into an ice cube? As the heat is supplied to the ice, the temperature of the ice continues to climb until it reaches its melting point. At the melting point, as the ice starts to melt and transforms from a solid to a liquid, the temperature remains constant at this point till the whole solid melts. If the temperature is not increasing, then what happens to the thermal energy, which is supplied to the ice cubes? The energy which is supplied to the ice cubes at their melting point is utilized in breaking the crystal structure of ice and converting it completely into its liquid form. Thus, even though the temperature remains constant, thermal energy must be given to the ice so that it can be converted from solid ice to liquid water. As the heating continues, the temperature of the water starts to rise. Why the temperature keeps on rising? This is due to the constant rotation of heated molecules in the fluid, which takes up the thermal energy provided to the liquid water and converts it into its own kinetic energy. When the temperature of the water reaches its boiling point, the temperature stops rising till the complete liquid water in the container turns to water vapor. Why is it so? The reason is the same as that for melting point. The energy which is supplied to the liquid water at its boiling point is utilized in breaking the interactions present between the liquid molecules and converting it completely into its vapor form. The temperature of the water vapor keeps on increasing as more thermal energy is added above the boiling point. By heating the ice, it may be melted into water and then converted into water vapor. So, what will happen if we remove the thermal energy from the water vapor? Removing thermal energy from the water vapor, that is, cooling it, will lead to the transformation of water vapor to water, and finally back into ice. This implies that the interconversion of the state of water is reversible. This clearly shows that the quantity of thermal energy contained in a material determines its state of matter. Thermal energy must be supplied to, or withdrawn from a substance, in order for it to shift from one state of matter to another.